what does pupil? The light enters through that pupil. Retina is the screen, or we can say that it is light sensitive. It has light sensitive cells which on which image is formed. Okay, we have talked about the blind spot. We have talked about the fovea. We have talked about cornea. Okay, power of accommodation. We have talked all about this. Okay, and we have discussed the short sightedness and the long sightedness. Okay, the defects of eye. Okay, got it. Got
Yes,
it.
sir.
So may I know that what are the causes of myopia and how it can be corrected? Myopia. Myopia means short-sightedness, as you are very much familiar. And a myopic person can see nearby objects. Means short-sightedness, short thing means means a person can see objects that are nearby to it. Okay, so we considered it as myopic eye. Okay, and it has and how it occurs by the elongation of eyeball. Means the image start forming on the in front of retina. Okay, the image start forming in front of retina. Okay, got it.
Yes, sir.
Yes, sir.
So this is due to elongation of eyeball or excessive curvature of eye lens. Okay, means if the power of eye lens become more, then it results in myopic. So it can be corrected by using concave lens. Okay. Then we have discussed about the hypermetropia. Hypermetropia, the causes of hypermetropia, we have written this one, and their correction we have also discussed this one. Okay. Now talking about the presbyopia. Presbyopia, we can say that it is another type of disease, or we can say that it generally occurs at the old age, or it's called old age hypermetropia. Okay, in this the person can neither see a nearby object nor it is able to, or he is able to see the distant objects. Okay, clearly. So it has both myopic and myopic as well as hypermetropia. Okay, so this is called presbyopia. So it is a defect due to vision of old person cannot see nearby object clearly due to loss of accommodation of power. Not only the nearby object, he or she can't see the distant object also clearly. So the near point of the eye that is called presbyopia gradually reduces and becomes more than 25. Means a person need to see the object if he wants to see, though to have seen that they used to see things that are means they used to keep if they want to see the newspaper or read the newspaper, they need to put it away from 25 centimeter. Okay, so this is due to gradual weakening of ciliary muscles. Okay, we can consider this one, diminishing of flexibility of eyelids. Okay, got it. Diminishing flexibility of eyelids means if the eyelids is not flexible, it means at the time become more, the ciliary muscles become weaker and they are not able to resize the eye or change the focal length of the eyelids, and due to that it happens. Okay, so it can be corrected by using cylindrical or bifocal lens. We called it can be corrected by using cylindrical or bifocal lens. Bifocal lens are those lenses that are going to have two types of lenses simultaneously to read the nearby objects. We have here like this. We can see this portion to see the nearby object, and to see here this is to see the distant object. And if you want to see the distant object, means a person can see the distant object, means it is if it is using this lens to see the distant object, means he or she cannot see the nearby object. He can see the nearby object. So we can see that this portion is simply, they're the two types of lenses, combined lenses together. Okay, got it. They're the two types of combined lenses together, and this lens is used for seeing for reading the nearby objects. Okay, got it. And it is concave convex lens. It is convex, and here it is concave lens. Okay, so they are the two types of lenses, and this together is called bifocal lens. Got it.
Yes, sir.
So please note the important points of this presbyopia. Note it fast.
Noted, sir.
Everyone? Shweta, you also?
No, sir.
Note it fast.
Done, sir.
Okay. Let's talk about this one. Advantage of this will not be asked in the examination. So what type of lens is used? What type of lens is used to correct hypermetropia and myopia?
Convex is used for hypermetropia and concave for myopia.
Yes. Concave is used for hypermetropia and concave is used for hypermetropia. Okay, name the defect of vision in eye which loses its power of accommodation due to old age. That is called
Presbyopia.
presbyopia. Okay. Next is what is the 4 point of our eye suffering from myopia? What is the
Infinity?
what is the 4 point of the person suffering from the myopia? If myopia means short-sighted, he can see the distant object but not the far object. So we can say that not infinity. Far point will become less than infinity. Okay, got it?
Yes, sir.
Got it. Next is what is the name? What is the name of this? Same question. This one is the name. You can read. Your friend can read a book perfectly. This is your okay. We read a book perfectly well, but cannot read or the writing things that are written on the board unless she or sit on the front row of the class. Is she is having short-sightedness or long-sightedness?
Short-sighted.
Short-sightedness. Very good. Again, differentiate between hypermetropia. You can do this. What is presbyopia? You can do this. Okay, and this one. This one. How is the amount of light entering the eye can be controlled? Tell me. How is the amount
With
of
the
eye
change in the size of the pupil
by changing the
controlled
size of
by
the
the iris.
Okay. Now talking about these questions, the near point of a person is suffering from hypermetropia at 50 centimeter and from his eye. What is the nature and the power of the lens required to correct this defect? Tell me. Nature and the power of the lens required to correct the lens. Let's do some question regarding to this one. Okay, this is an important topic. So let's have this.
Convex.
A person the near point, look at this, a near note everybody this question, please note this question in your copy. The near point of a person suffering from hypermetropia means he can see the distant object, okay, but not the nearby object. So then we can say that the maximum distance he can see is 50 centimeter from his eye. What is the nature and the power of lens required to correct this defect? Note this question in your copy. And let's have the NCERT question regarding to this one. Wait a minute. Let me pick up the NCERT book.
Done, sir.
Okay.
Done, sir.
First, let's do these questions. Then we shall be going to the next part. You know what is power of the lens? You know what is power of the lens? Power of the lens.
Magnification.
Power of the lens is, we can say that it is
1
1 by
by the
f.
reciprocal
Uh,
of focal
res-
length.
yes, we can say that power of the lens is 1 by focal length, but focal length here should be in meters. And if it is in centimeter, okay, then it should be 100 upon f.
100
Okay,
by focal length.
so power of the lens can be defined as, this is focal length divided by, we can say that is, this is 100 if it is in centimeter. Okay, got it? You understood?
Yes, sir.
Yes,
Okay.
sir.
Okay, so if this is the next question, let we will do that one also, but let's do this first. Okay, let's have this question. So here's the question number 6. Okay, here's the question number 6. A far point of a myopic eye is 80 centimeter in front of her. What is the nature and the power of the lens is given to you? So here, if the far point of a myopic eye means a person can see short sightedness is there when the object
Nearby
high,
object.
but cannot see the distance of the far point is maximum far point is 80 centimeter, means he can see the object, okay, in front of his eye. And what is the nature of the image required to correct this problem? What is the nature and the power of the lens required to correct this problem? Okay, so if I'm so myopic eye means he can see the short distance but cannot see the distance that are at means that are far away from us. Okay, so if I talk about this question, let's take he can see 80 centimeter. Far point is 80 centimeter. Okay, far point is 80 centimeter. 80 centimeter. And he need to see the object infinity, means far point is maximum, but he need to see the object that has placed at infinity. Okay, so here it is infinity. V is infinity. Okay, so if I talked about you that this is u, you can consider this one as u. Okay, so what is the formula for the lens? 1 upon f is equals to 1 upon v minus 1 upon
Minus
u.
1 by u.
Okay, will it be a means if it is a concave lens, or we will use concave lens or convex lens?
Concave.
Concave lens. For pi of a myopic eye is concave lens. Okay, concave lens has focal length, negative focal length. Okay, got it? Got it?
Yes.
So here we will convert this one. This is that the object should be placed at infinity. So here u is infinity. U is infinity and v is this one. Okay, minus it. So if I talk about this one, v is real images form, that will be on that side of the lens, that will be real. So we'll consider this one because this concave lens always form virtual image and that is on the same side as the object. So it will be going considered as v as minus 80. We will write minus 80, then minus 1 by infinity. Minus 1 by infinity. Got it? Got it? Then
Yes.
1 by f. Okay. So 1 by infinity means when you are dividing a number 1 by a very huge number. So this will be considered as 0. So we can consider this as 1 by 80 is equals to, what is it will be? Tell me. This will be equals to 0. 1 by minus 80 minus 0. Okay, this will be 1 by f. Then you know power is equals to 100 times into 1 by f. If it is in centimeter, focal length is in centimeter, so we can write it the value of this one 100 into 1 by 80 minus, then power of the lens will be 100 into divided by 80 minus, you can cut it 0, then you will get 10 by 8, then you will get 1.25. The power of the lens is minus 1.25. Okay, got it? Diopter. You understood, everybody?
Yes, sir.
Note it. Note this question. First, note, have you noted the question? Note this question first. Question number 6. Note this question. Noted question? Tell me.
Noted, sir.
Done,
Noted.
sir.
Okay. Done? Okay. Now it's solution. Note the solution also. Note the solution also. Done?
Yes, sir.
Okay. Now note the next question. That is question number 7. Note this question number 7. Everybody, question number 7. Mar and you, Saima. Why were you late today?
Sir, I didn't get the link properly, and I was trying to join. Okay, my laptop was getting stuck. It's also still getting stuck, but it's fine now.
And you, Saima?
Yeah, I didn't know that the
I didn't.
class was at 5 o'clock. Sir, I didn't know the time of the class.
Don't know the timing of the class. Okay. Done? Done? Noted?
Sir.
Noted, everybody? Question number 7.
Yes, sir.
Okay. So let's do this question. What is saying? A near point of an hypermetropic eye is 1 meter. Okay. So the near point is of an hypermetropic eye is 1 meter. So what is it? Is it a V or U? That is V. Okay, that is V. So V is minus 100. 1 meter means 100 centimeter. And U is, it is saying that in the question that the near point of a hypermetropic eye is 1 meter. So near point is actually 1 meter. So image is forming at 1 meter. So we can write the image distance, that is 1 meter. And the power of the lens required to correct, what is the power of the lens required to correct this one? Assume that near point of the eye is, here it is said that near point of an eye is 25 centimeters. So the near point here is 25. It is, if it is not given, then you have to assume that it is 25 centimeter. Okay, got it? Then 1 upon f is equals to 1 upon v minus 1 upon u, and use this by using this formula. Do this one. Do this one. Calculated?
Is it 4?
Is it 4? Let me check. 1 upon F. Upon 1 by V. What is V? Is minus of 100. Then minus. Then minus of 1 by 25. So 1 by 100. Then minus. And this is minus U. This minus minus. These two minus sign will get plus. And you will get plus of 25. Then 1 by F is equals to, then you will get here, what you will get? Minus 100. So take the LCM as minus 100, or you can take this minus to this numerator. Okay. So you can bring this minus to here. So you will get 100. And this is minus 1. And then plus, you have to multiply this one by 4. This one also by 4. Then you will get what? You will get 3 by 100 is equals to 1 by F. Got it? Got it?
Yes, sir.
Now you know the power is equals to 1 by F into 100. Okay, because it is given in centimeter. So we can write it P is equals to 1 by the value of 1 by F is 3 by 100 into 100. This 100 will get cancelled. You will get P is equals to 3 diameter. P is equals to 3 diameter. So what you notice here is that you have to always for a myopic eye, if it is myopic eye, then myopic eye means short-sightedness, but you cannot see the long. Here for myopic eye, U is infinity. Okay. For myopic eye, U is infinity. And for hypermetropic eye, okay, U is minus 25 centimeter. Got it? You need to keep this in your notebook. Note it down. For hypermetropic eye, when you need to calculate the focal length of the power of the lens during solving the numerical, and you have to use this one. For myopic eye or for short-sightedness, U is infinity. And for hypermetropic eye, okay, for hypermetropic eye, we have U as minus 25 centimeter. Okay, note it down. Then the question will be easier for you. Note it. Abir, you note down this question. Have you noted this question?
No, sir.
This is question number 7 of NCRT. Question number 7 of NCRT.
Okay.
Done.
Done, sir.
Done. Done. You, Amar, Shweta, and you,
Done, sir.
And
Done.
Shama. Done.
Yes,
Okay.
sir.
Okay. Let's now you calculate this question that we were doing on previously. Okay, do this question. That one. Now do question number 3. Now you have done this type of question. Now you can solve this one. If the near point is given to you and this is a hypermetropic eye, so what is U in this case for an hypermetropic eye? Tell me what is U?
25 minus
Twen-
25.
Minus 25. Very good. And what is 50?
V is 50.
V is 50. And you need to keep in mind that you have to take both these things, means V and U, as negative. Okay. Don't think that it is a hypermetric. This is noted. Done. Try to solve this one.
Done, sir.
What's the answer? What's the answer? Shweta, you told me done, sir. Or you have noted the question only. Amar, you get the answer?
Sir, power is 2 diopter.
Power is 2 diopter. Okay, let's check. Let's check. So if we have this one, 1 by F is equals to 1 by V minus 1 by U. Then you have taken V is minus 50, then minus 1 by 25. Then you will take minus 1 by 50, and then this will become plus 1 by 25. Then you take the LCM. We have to multiply this by 2. You should multiply this, you will get 50 equals to minus 1 plus 2. You will get 1 by 50 as 1 by F. So P is equals to 100 into 1 by F. This is 100 into 1 by 50. You cut it, you will get 2. Power is 2 diopter. Okay.
Sir,
Yes. Yes, Shweta. I say something.
yes, sir. Sorry, sir. Some network issues.
Okay, now you have done this question.
Yes, sir. I got the answer. 1 by 50.
You get
is-
F is 1 by 50. 1 by F is equals to 1 by 50. Now you know that P is equals to 100 by F. If it is in centimeter, then you know we can write it 100 into 1 by F. This is 100 into 1. The value of 1 by F is 1 by 50. You cut it, you will get 2. Okay,
Okay,
got
sir.
it? Power
Yes.
is 2 diopter. Okay, so let's move further. Let's move further towards the prism. Okay, there are some other questions also. Let's check these questions also. Okay. What is short-sightedness? Will you be able to explain this one? And ray diagram for this one, we have done this one also. Okay. Let's talk about the prism. Prism, you know that that is also a refraction. Okay. Prism. Prism, what is prism? Prism is a pyramidal or piece of glass with 2 triangles bases, means 2 triangular bases and 3 rectangular. We can say that 3 rectangular lateral surfaces. Okay. Got it. The angle of prism, this is called this top one is called the angle of as angle of prism. We call it as angle of prism. Okay. And you know that whenever light is incident like this, so now it is, if we can draw the normal on the surface, then again it will follow this is the angle of reflection, sorry, angle of incidence. And then since it is a normal to this one, so it should not be going like this. It should bend towards the normal. So this is normal, so it should bend towards the normal, like it bend like this way. And then again, if I draw the normal over here, normal line over here, then again it should bend. Now this is the normal line, and now the light is coming from denser to rarer medium, so this is the normal. It should go like this, but it should bend away from the normal because light is, we can simply say that
From denser to rarer.
because it is moving from denser to rarer medium, so it should move away from the denser, away from the this one. Okay, got it? So it should bend like this. So this is the prism that we need to understood this one. So let's start studying this one. Draw this diagram, please, in your copy. Refraction through glass prism. This is called incident ray. You know very well, this is incident ray.
So what is O?
O, O is the
Yeah.
point where the incident ray and the emergent ray meets. Means they are going to meet if they
Okay.
don't bend. Okay.
Okay.
So we can consider this one as this is the incident ray. And they should be going like this, but it should bend away from the normal, bend towards the normal. So this is the normal line. So it is bending here. Now again, this is the normal line. Now it is going from denser to rarer medium. So it should not go like this. It should bend away from the normal. When the light travel from denser to rarer medium, so it should bend away from the normal like this. This is the emergent ray. This is the incident ray. Okay, and this is called the angle of prism. Is called the angle of prism, and this hole, you know that this is the, if I continuously grow this one like increase this line like this, and this is the emergent ray. Okay, so this angle is called angle of deviation. What we called it? Angle of deviation. So make this diagram first and note down the definition of angle of deviation. Angle of deviation. Done. Nobody is answering.
Sir,
Do it fast. Done. Abir, done. Shweta,
Yes.
Mark. Okay. Now, what is angle of deviation? You know that it is the angle between the incident ray and the 1 marks question may be asked from this one. Now, as you know this one, that this is a question here. Okay. And that when we have a sunlight that is going to have 7 colors, so it, you know very well that different color of lights have different wavelength. Okay. Got it? Different color of lights have different wavelength. And you know that every light has to travel a different, means you know that if light is traveling like this at some angle here, so why in glass prism, let me explain you here that you know very well that let me explain you in this one in detail, that why, how does this happens, and why does the light is split into 7 colors when it passes through a prism. Okay, and why not in through the glass prism? So as you know that this is a 7 color. Okay, and if a light falls over it, okay, then it is a normal. Then these are the 7 colors, and these 7 colors have to travel equal distance. If it is light is traveling or if it is bending towards the normal, then it has to travel equal distance. They got it split, and this has to travel equal distance. Okay, but what you see here that in the prism, the color that bends less, for example, this red color, that for example, red color bends less. So now you know that it is being scattered into here. And now the red color is bending less, other colors are bending more. And since due to this less distance that is being traveled by here, this is the less distance, and this is the more distance. So due to less distance, because of this unequal distance traveled, okay, unequal distance traveled by this one, by the waves, these we can say that the spectrum or scattering of light takes place. Means if white light is incident over here and then it is traveling, then it gets split into 7 color because of this unequal distance traveled by the light. Light, I mean, different colors of light have different wavelength, you know, and their speeds are also different. So if they travels unequal distance, okay, then this results in scattering of light. Okay, got it? You understood? Okay, because this distance is not same. Here it is traveling, like for example, if I'm making this like this way, if it is like so, then here they are traveling equal distance. But before this region, this is the violet light, it get expelled. Red color is expelled out from here. Okay, then this distance is traveled by another light, then this another way color, this. So they are not traveling equal distance. This violet color, that is a violet color, this is traveling more than the other colors. The red color is traveling the shortest distance. Okay, that's result in the scattering of light. You understood? Understood, Kabir? Sorry, Abir and Shweta,
Yes, sir.
Saima and Ammar. You understood all?
Yes, sir.
Yes, sir.
So if I talk about this one, let you check it here. So if I talk about this one, here is scattering of light take place, and this you will learn. This is scattering or spectrum of light you will learn more betterly when you will study in 12th standard the wave fronts, or we can say that the wave nature of light, because we don't study the wave nature of light in 10th standard. We only study its particle nature. When wave natures means will help you to explain this one and to understand this one, that how you can understand this concept. Okay, so let's talk about this one. When a white light is passed through a prism, it is split into 7 colors and to constitute to form a band of 7 colors. This phenomena is known as dispersion. What we call it? Dispersion. Okay, got it?
Sir, is dispersion the same as scattering?
No, we can, yeah, scattering is means I was just wrong at this point. Scattering is when a light is uh, means hit on a surface, then it is splits into various direction. That is called scattering. And scattering of light is taking place. Here, the splitting of light into 7 colors is called dispersion. Okay, so corrected my point that I was just saying that is scattering. So that is dispersion. So dispersion means the light is dispersed into 7 colors. Okay, you understood? So note this point: when a light is passed through a glass prism, it is split into 7 constant colors of band. That is known as dispersion. Here, if I consider this one here also, like this, parallel light. So here, since this is traveling more distance in this medium, okay, so this and the red light is traveling less distance. So because of that, the light that is traveling less distance, okay, then it again means due to this one, there is means one color is emitting fast, another color is emitting at less distance. Means this color, red color, has been ejected out from this one, but this color is still in the glass. Okay, so they are just separated because of the unequal distance traveling. Okay, got it?
Yes, sir.
So now you understood. And what is a spectrum? The band of these 7 colors is called a spectrum. That is Vibgyor. Vibgyor. This is violet, indigo, blue, green, yellow, orange, and red. Okay, so these are the 7 colors that we have. The highest wavelength of this one is red color, and the lowest wavelength is of violet color. Okay, got it. So violet color deviates more, and red color deviates the least. Got it?
Yes, sir.
Now it is you need to understand that angle of deviation is inversely proportional to wavelength. Means angle of deviation. What was angle of deviation? What was angle of deviation? Angle of deviation is this one.
Angle between the incident ray and the emergent ray of the
And the
plastic.
emergent rays. So we can say that more the wavelength, lesser will be the angle of deviation. Means lesser deviation will take place. So red color has more wavelength, highest wavelength in the
So
in this
least
7 color.
deviation.
So it will be less deviated. Okay, so we can write here that this one. Note this one, that this one angle of deviation is not proportional to wavelength. Red color is least deviated and violet color is most deviated. Done.
Done, sir.
Now moving to the next point here. When we recombine, means if we are recombining this one, okay, again, then this 7 colors get again, when they are again dispersing, means we are just recombining this one. So again, you see that when you see, you will feel that this will become a glass slab like this when you join this two. Okay, then every color will travel equal distance. Every color will travel equal distance. For example, here it was traveling less distance, red color, but here it will traveling more distance. And here it was traveling more distance, then it will be traveling less distance. So when you recombine this one, then again it will be converted into white light. Okay, this will start behaving like how it start behaving like it start behaving like a glass prism. Okay, so when we combine this one, then they join together, then it will gives you again white light. Okay, so draw this one also, dispersion, then again recombination. When you're done, please let me know. Okay.
Done, sir.
Okay.